Sous vide is the art of letting your food come just to that perfect temperature over time. But how do we mesh that with the half-baked nature that typically is zero trust? Jason, we saved the best for last.
Great. Thanks, Bryson. And thanks to all of you for attending. And thanks to Leslie and team for putting this event together. It's amazing. It came together so quickly, and it's really been pretty incredible what we've been able to do, and some of the presentations that I've seen. So let's go ahead and dive in. We're going to talk about sous vide cooking and its connection, somewhat tenuous perhaps, to zero trust security. And the goal here really is to introduce you to this major concept that's going on, this major trend in information security called zero trust, and to try to tie it back to reality. And it, like many things in our industry, it's become a buzzword, and it's become abused and overused. And I want to try to provide some foundations to put in place here around what it is, what it isn't, and why it's meaningful and why it's important for us to do that. So let's go ahead and talk about me. So I work for a company called Appgate. My role is Chief Product Officer, which means I run product management. I set the product roadmap. I spend a lot of time working with our customers and prospects. I also have a volunteer role with a group called the Cloud Security Alliance, where I'm co-chair of the working group called the STP Zero Trust Working Group. And I recently wrote a book about zero trust that you can see there. More importantly, or the other side of my personality, is I love to cook. You can see me here with some Parker House rolls and with some wings on the smoker. I couldn't find a photo of myself actually sous videing, but I do that a lot. Cooking is really important to me and my family, something I grew up doing with my parents. And I really love doing it with my wife and daughters. And I encourage you to embrace it and enjoy it as well. Professionally, I've been working for software companies my whole career, about over 30 years, in a variety of roles. I started out in about 7-10 years doing software engineering, building distributed systems and network applications and middleware. Did a brief stint in technical consulting, and then really spent the last good 15 plus years in product management, really focusing on information security with an emphasis on identity management and network security for about the last 10 years. So zero trust is, as I mentioned, it's been abused in the last couple of years. It's a major shift and trend in our industry. And there are definitely, I would say, skeptics, healthy skeptics, and some cynics out there about this. And there's memes like this that are going about where people say, well, zero trust is nothing more than multi-factor authentication and network segmentation and the principle of least privilege. And I don't understand all the hype. And the reality is, of course, that the zero trust, there is a lot of hype around it, but it's also a very substantial and, in my mind, a very significant shift in how we're thinking about and architecting and approaching information security in our enterprises. And of course, it uses MFA and network segmentation and embraces the principle of least privilege. But it also builds on them and utilizes and consolidates or integrates them in pretty novel and interesting ways. Really, I think the right way to think about it is that zero trust is a security philosophy, a set of principles or tenets, and a way that can and should influence our thinking. If we think about how poorly our enterprises are doing at defending themselves against attackers, both criminal and nation state, it's clear that there's some significant problems in our industry that we have to do a better job of addressing. And I really believe that the principles of zero trust, when done properly in an enterprise, make them much, much more resilient to these types of attacks. And hopefully what I will do in this presentation is communicate to you some of that substance, get you excited about learning it, and helping you to help your enterprise go down this journey towards a much better place. This diagram here comes from Gartner, the consulting and industry analyst group, and it kind of outlines roughly the general life cycle of a term or a trend in our industry, where something happens to start it out, and then you get a great deal of hype, what they call the peak of inflated expectations. And then, of course, things get overhyped, it's harder than the marketers promise, and you enter the trough of disillusionment, and ultimately, get up to the plateau of productivity. And this is not an exact science, and I couldn't exactly tell you where zero trust is on this thing, or even the shape, if the shape of the graph really applies. But there's certainly a great deal of hype around it. But there's also real world enterprises that are using this and making significant benefits, to obtaining significant benefits from a security and efficiency and a user experience perspective. So of course we have to ask ourselves, all right, why are we doing this? And in order to explain, other than bemoan, the state of information security, I think it's important to think about things a certain way, which is, from a network perspective, our core networking technology, from when this was invented in the 1960s and 1970s, the principle of networking is all about, let's make it really easy for these devices to connect to one another. Let's make it really easy for our packets to get from point A to point B. And I think we all agree our networks have done a fabulous job at that. There's a little history of networking and security. I'll give you a reference later from the Washington Post that is really fascinating. That talks about the founders and the pioneers of this technology in the 60s and 70s and how they did this. And they did a fabulous job with what was very primitive technology at the time. The challenge we have is that from a security perspective, what we're trying to do is protect and control access to applications and the data in those applications. And number one, we want to restrict access there. But number two, the very vocabulary is completely different. It's, how do I only let authorized people access authorized data? And you can see, we're not even using the same words. We're talking about people and data up at the top. And we're talking about devices and packets at the bottom. And this gap underlies a great deal of problem in our industry. It's a semantic gap, but it's also a technical gap, because if you look at how most enterprises and their networks and their IT and security tools and teams are set up, you've got very often a networking team that solves the problems at the bottom, and you have a security and application and data and compliance team that's trying to solve the problems at the top. And because these are orthogonal in many ways, it has resulted in bad practices and resulted in our enterprises that have a very weak security stance, and we see the results from that. But the good news is that we can, by looking at this fabulous stock photo, learn a couple of things from this gap. So the first is that we fundamentally have to understand that TCP/IP is a really weak foundation for security because it's built on this notion of implicit trust. It operates on the idea of connect first and authenticate second. And if you look at even all the way down to the networking protocol, that you've got a system that's sitting across a network from you, whether it's a LAN or the internet, it has an open port. What that means is you can send the first part of a TCP connection handshake, a SYN, and it'll respond to you back with a SYN-ACK and say, great, you can connect to me. So all the resources on the network are visible. And it's only after you set up some sort of network connection at the network layer that then you have some sort of authentication. Today, this usually happens at an application level, like SSH login or maybe a web application. And that's really backwards from how you would want things today. If you look at all of these weaknesses and all these vulnerabilities that are taken advantage of by criminals and nation states because these services are exposed to them on the internet, that's exactly backward from how you'd want to do it, given what we know today. The second issue is that TCP/IP is a very poor, or has a very poor policy language. What I mean by that is it forces us to use these very crude network-centric terminology to basically ask and answer the question, should this source IP address here, this 192 address, get access to this target address and port, this 10.5 address over here? And the answer is, again, we're forced to answer it as either a yes or no, an allow or a block. And that's not a very good answer either. So the end result of this is that our networking team, who is often so busy making sure the network is up and that our packets can get efficiently from point A to point B, have no notion or no capability to tie that very impoverished policy language of source IP and target IP to what the application and the data owners care about, which is people and identities and types of data. So we end up with these very broad and wide open flat networks where when you get onto a corporate network, whether it's through a VPN or when we were going to the office, you would plug in or get on the Wi-Fi, and you would have access to hundreds or potentially thousands of services running on that network. And you really only needed 5 or 10 or 20 to do your job. And that, of course, violates security best practices. It violates this principle of least privilege. And we see this time and time again getting used very effectively by malicious actors to exploit and to take advantage of this and to just cause lots of problems in our organizations. And this is because our network teams kind of give up. They say, well, I have no idea who is coming in, under what IP address. I'm just going to do my job and get the network devices connected, and I'm going to rely on authentication at the application layer. And that's a very ineffective security stance, given where we are today. So this notion of zero trust came about in about the last 10 or 12 years. And in the past few years, I would say 2 to 3 years, it's really gained a high degree of visibility and prominence. So the National Institutes of Standards and Technology here in the US published a document called Special Publication 800-207. And it's a very good document. I recommend you take a look at it. It's freely available. And they define zero trust as a set of cybersecurity paradigms that move defenses from static and network-based perimeters to a focus on users and assets and resources. And you can see what this is starting to address that semantic gap where instead of modeling access based on IP addresses or a hard perimeter, the classical castle wall around our enterprise, we actually now have to work with these objects around identities and users and the assets and the resources that are being accessed. That's an important and significant shift. It's one of the key elements of zero trust. Second definition of zero trust comes from the noted cybersecurity expert, President Joe Biden. He issued a executive order in May of 2021, and it was pretty important, pretty impactful on the US government. It codified both the definition of zero trust, but it also gave a mandate to the US federal government agencies to embark on a pretty aggressive mission to define zero trust type architectures and to invest in them. This order defines zero trust as a security model that eliminates implicit trust in any one element, node, or service, and instead requires continuous verification of the operational picture through use of real-time information from multiple sources to determine access. So what this is doing, as you can see, it's also talking about another element of zero trust, which is its requirement and need to not be a silo, but to really embrace its role as integrating lots of different elements of the enterprise, both from an IT infrastructure perspective, as well as from a security infrastructure perspective. And if we kind of boil this down to the core tenets or principles of zero trust, the first one is to ensure that all resources are accessed securely regardless of location. And what we really need to interpret that as is that no matter where the user or the identity is that's accessing a resource, and no matter where that resource resides, the zero trust security model needs to apply there. And this is a big step forward, actually, because if you think about how traditional security happens is you've got a remote access solution, typically a VPN, and that provides remote access. And you have a completely different set of access control mechanisms and technologies for when users were in the office, something like a network access control solution. And those were completely different worlds. And it doesn't make sense anymore, especially as, number one, more and more resources that people are accessing aren't on premises, but they live up in cloud-based or remote data centers. And two, of course, now you've got anywhere between 80, 90, or 100% of your workers working remotely. You need a solution that doesn't have a siloed and distinct access control model for remote and on-prem. You need a holistic solution that isn't about remote access, it's just about secure access. The second principle is to adopt a least privilege strategy and strictly enforce access control. So that's about, I get on the corporate network and I shouldn't see 2,000 services running. I should see the 10 services that I need to do my job. And anything else that I need, there needs to be most likely a business process around me getting access to that. As long as I can stay productive and do my job, that shouldn't matter to me. What that does is it really makes the organization a lot more resilient. So I make a mistake, I click on some malware, I get a malicious software in my device, and guess what? Now that malware has access to those 10 resources that I have access to on the corporate network. That's bad, but it's not really bad because that malware can't do network reconnaissance. It can't all of a sudden scan all 1,000 services on the network, look for default passwords, look for vulnerabilities, and start to exploit them. The blast radius of the attack is very limited just to those 10 applications. And because everything else that I can't access is prohibited, it can very easily be detected by our security and monitoring solution. we've really increased the signal to noise ratio. So if this malware now starts to do a port scan or starts to enumerate IP addresses and try to connect to them, it's much easier for either our network or security operations team or our monitoring software to notice that and to really be able to respond quickly, which really leads us to the third point of inspecting and logging all traffic as the final zero trust tenet. And this really comes from this notion of assume breach. Assume that you're every day going to have a compromised device on your network and some level of malicious traffic. What does that mean from a monitoring and operations perspective? And because zero trust really approaches things from an identity-centric view, it ends up augmenting or enriching network log traffic, and it makes it easier to tie actions that are coming from, let's say, some translated IP address to an actual human being and their device, and makes it a lot easier to track this down and to respond to it. So let's take a look at how zero trust compensates for those two weaknesses that we talked about. So the first is it actually reverses this order in a way that makes it a lot more secure. So zero trust says we're going to require some sort of authentication, and there's different ways to do that, but some sort of authentication before a network connection can actually happen. What this means is that your services aren't accessible to the millions of malicious actors who can access it across the internet. Your services will only be network accessible to your properly authenticated and onboarded users across the internet, because of course you want them to have remote access. When they connect, you're also enforcing the principle of least privilege. I'm moving away from the world of I sign on to a VPN and I see 2,000 servers on my corporate network, and we're moving to a world of I just turn on my device, I authenticate, and I can get access to the 10 resources that I need. The second piece I think is really, really interesting is zero trust enables a much richer policy language for determining who should get access to what. So we're moving away from this network-centric view of source IPA and target IPB, and instead we get to pose the question, should Jim have access to our production SAP server? That's a really interesting question, because guess what? We know a lot about Jim. Jim's a person. Jim works for us. Jim has a certain role in the company, and we can very easily determine, yeah, Jim's in the finance team and he's got this type of job, so he really does need access to the production server. Or no, Jim works in a sales role, he doesn't need access to the production server. And really, the answer to this question also is interesting. It depends, right? And what it depends on are a lot of really interesting and relevant questions that are relevant not to network engineers, but they're relevant to our security team and to the business and to our compliance team. Is Jim's machine patched? What's our current security posture on the network? Where in the world is Jim connecting from? Those types of things are actually really, really meaningful, and what zero trust allows us to express in an access policy, in many cases for the very first time. And we'll talk about the service desk example in a minute, which is one of my favorite use cases. So if we look at what a zero trust model might look, this comes from the NIST document, and there's a lot going on in here, but the key points are, first of all, there's a separate control plane and the data plane for the enforcement mechanisms. In the control plane, there is the policy decision point, or PDP, and that's the brain of the system that makes the decisions around should the subject, Jim or Sally, get access to the enterprise resource. The access actually occurs in the bottom part through the data plane, and you can see it's gated or controlled by a policy enforcement point, or a PEP. And the policy enforcement point receives its instructions from the policy decision point. Policy decision point, most importantly, can't make those decisions in isolation. You see those 8 boxes on the left and the right side. That underscores the need for a zero trust system to be tied into lots of other elements of an enterprise, whether it's an identity management system to authenticate the user, a security monitoring system, a SIM system for looking at logs, a data classification system, et cetera. All those things, we're going to provide both data and events for the zero trust system for the policy decision point to decide, should this identity, should this subject be allowed to access this resource at this point in time? And we look at this from a slightly different view. You can see what we really need, what Zero Trust really enables us to do is across our very heterogeneous set of resources shown at the bottom here, really wide variety of on-prem, cloud-based, lots of different types of technology. We could be accessing database servers or more modern containerized workloads or unmanaged IoT devices. All of those things need to have policy enforcement points that logically and actually physically on the network sit in front of them. And the identities shown in the upper right will authenticate through the policy decision point to the identity provider. And the policy decision point will look at both contextual information about the user and their device and about everything else the enterprise knows about that user, as well as events that might happen. And I'll show you a flow of what one particular architecture around this might look like in a couple of minutes. But this is really the conceptual view of tying how the policy decision point is going to make decisions and have those policies enforced across what might be a pretty heterogeneous infrastructure of lots of different types of policy enforcement points. The Zero Trust principles I mentioned can actually be deployed in a variety of different architectures. And there's about 4 or 5 common architectures that I've kind of put in place in the industry. I'm going to talk about one of them, which is the enclave-based model here. And essentially, you can see our policy decision point up at the top in the control plane, and the policy enforcement point that sits in front of what's called a resource enclave. So you can think of this as the entry point into an enterprise network with, in this example, in this architecture, a bunch of resources that sit behind the path. And of course, the way the network would be set up is that those resources can only be accessed by traffic that goes through the policy enforcement point. In this example, the user has also has a piece of software running on their device. Many Zero Trust systems utilize agents that run on user devices. Many of them also have clientless options. And of course, there's trade-offs for that. But this is kind of the simplest conceptual model. So let's dive into kind of one more level of detail about how this works. And what I'm going to be showing you is an architecture called the Software-Defined Perimeter Architecture. And this comes from the Cloud Security Alliance, which is an open and nonprofit industry consortium. And this is going to match the image on the previous slide. So you can think about this as, up at the top, I have what's called the controller, which acts as the policy decision point. And I show one of these policy enforcement points, what's known as a gateway at the bottom. And of course, in a real architecture, you'll have lots of gateways spread around the enterprise network. And then we have a user that's running the SDP or the Zero Trust client on their device. The software-defined perimeter architecture takes a couple of really interesting angles to this. So the first is, excuse me, that the controller and the gateway need to be accessible globally. We don't know where the user is going to be on any given day, and they will be accessing this across the insecure internet. So what the SDP architecture does is it utilizes a basic form of cryptography and a shared secret to hide those components on the network. So this is the reversal of the traditional network connection that we talked about. So what Zero Trust says is, if you're not an authorized user, if you haven't been properly onboarded, or in this case, if you don't have the right secret key on your device, you can't even establish a network connection to these things. So the controller and the gateway in this world are invisible on the network to unauthorized hackers. They won't respond to a ping. They definitely won't respond to a TCP SYN. So they're much, much more resilient in that case. What the client, though, because it has this shared secret, it can generate a cryptographic packet and basically tell the controller, hey, here I am, let me establish a network connection to you. And the controller will look at this and say, yep, you're good. It'll let it establish a network connection, TCP connection. And on top of that, it will then establish a TLS connection. So the session is encrypted. And then we actually get to the second level of authentication, where the user will authenticate through the controller to the enterprise identity provider. And this is important because now the controller, as the policy decision point, now knows a lot about the user. We know it's Jim, and Jim's in these directory groups. And maybe I can also retrieve information about Jim's device from the client that's running on there. Is his antivirus running? Does he have an enterprise issued certificate, et cetera? The controller then makes its decisions. it will evaluate the policies and make a determination, okay, great, I'm going to allow Jim to access various resources. So it needs to communicate that, and it does that through this mechanism called live entitlements. It's a piece of data that gets sent down to the client. All right. Bryson, was there a question?
Yeah, we have some confusion about the control plane versus the data plane, if you could cover that again.
Absolutely. So let's go back to that. So control plane versus data plane separation is a common paradigm. It's used in software-defined networking as well as in lots of other elements in our world. And essentially, what it does is it uses a different communications channel, logically or physically, between the mechanism that controls the system and the mechanism that's actually manipulating or transmitting the data. So it makes it more secure, and it also makes it more reliable, because let's say this data plane somehow gets saturated or compromised, our control plane would still be open and available, and the policy enforcement point in this picture would still be able to communicate with the policy engine. Okay, I hope that answered the question. Where were we in the cycle? So the user is authenticated, the controller has acted in its role as a policy decision point and communicated down to the client the set of resources that the user should be able to access at this point in time. So the client now takes this piece of data and looks at it and says, okay, great. I know I'm allowed to access some resources that sit behind gateway A, that's IP address B. And it will go through a similar step of constructing that cryptographic packet, establishing a network connection and a TLS connection, and then sending those entitlements to the gateway. The gateway would then further evaluate those entitlements and then be able to establish a logical connection from the client to the gateway, through the gateway, I should say, to the target applications that this user has access to at this point in time. And the dashed line there represents the resource enclave that sits behind the gateway. The beauty of this is that those entitlements that get passed down to the gateway don't have to be fully complete. They could be host names, or they could actually use descriptive metadata to let the gateway actually look at the workloads, its environment, and make some decisions at runtime based on changing attributes in the environment. So you can easily imagine, for example, I've got workloads running in that environment, and because I work in, let's say, a DevOps type of world, they're continually shifting in their state. They're going from a dev state to a test state to a production state. And clearly, as those workloads change from one state to another, the access that different people have needs to change. And that can be done very dynamically by the gateway itself, and not have to force any user to make any change to log out, or to force any kind of disruptive activity on the network. So let's take a look at one more picture here. So this is zooming out a little bit, and you can see we still have our user in the middle and a gateway and a controller sitting in front of a set of resources. But what the software-defined perimeter architecture does, and by extension, what we should think about it as Zero Trust, is it really puts the user at the center of the picture here. So you can say, logically, I'm sitting at the middle, I've got 4 encrypted connections through 4 of those policy enforcement points, and now I'm accessing resources that sit in these 4 very disparate environments. And the beauty of this is, number one, that's completely transparent to me as a user. I just turn on my device, maybe I authenticate, and now I've got access to these devices and to these resources. I don't care where they are. I don't have to remember to turn on my VPN or turn off my VPN. And if things move around, if the enterprise decides to move resources from on-prem up to a cloud environment, again, that's going to be completely transparent to me. The other thing that's interesting about this is that it changes the network topology. So no longer am I required to have a single entry point onto my enterprise network like a VPN provides, and then have some sort of enterprise wide area network to have my traffic traverse and go over a fairly slow and typically very expensive wide area network like an MPLS. It's much more efficient for me to have this direct connection, and enterprises can start to reduce the cost and usage of WANs, MPLS, and things like that to have a much more efficient model like this. Finally, we're talking about users here, but in fact, what Zero Trust is all about is about identities. And servers, or non-person entities, as they're called, can also be first-class identities in a Zero Trust system. And if you look at the bottom here, you'll see our application that's running in one of the cloud environments is actually acting as a client, just like our human client is. So that application will go through the same steps of authenticating with the policy decision point, getting some network entitlements given to it, and then having a secure tunnel to go through another gateway to get to the target resource. So this really makes it very easy for enterprises to define not just user-to-server policies, but server-to-server policies as well. So let's take a look at our day with Zero Trust with our favorite employee, Sally. So Sally works at a large organization. She's director of finance. She's got an important job. She gets up early and connects in from home. This is a day pre-COVID, so she does go to the office today. She turns on her device, and there's her Zero Trust client is running on this. So it performs some sort of device validation to make sure, yes, there's a corporate issued certificate that's on this device. It hasn't expired. Antivirus is running. And she just accesses her cloud-based email, and as well as accessing a corporate hosted file share to download a presentation. She probably has to do some authentication along the way, maybe some MFA because she's working remotely. And that MFA can take various forms. It can be a one-time password. It could use a push notification to her mobile device. Lots of options there. Unfortunately, Sally clicks on a phishing link and gets some malware installed on her device, unbeknownst to her. A little bit later in the morning, she goes into the office and plugs into the docking station. So now she's on the hardwired corporate network. And because she's on the corporate network, she gets access to various resources. Let's say she doesn't have to authenticate again because she had to badge into the building. So there's a certain level of kind of trust, if you will, that she gets because she's in the building. But she only needs access to about 10 resources on the network to do her job. And those are the only resources that she gets access to. The malware on her device wakes up because it notices that it's on a corporate network, just based on the domain, and it attempts to do some reconnaissance, like a port scan. And because the system and the network is locked down, this is very easy for them to detect. So their security system notifies or detects this, immediately notifies IT, and also automatically quarantines her device. So her device will be cut off from any sensitive resources. She'll receive some sort of notification. Maybe it's an email, or maybe it's an out-of-band communication, like a phone call or a text. And her device will only be allowed to access the corporate help desk on the network. Sally notices this. She talks to IT, and they say, "Okay, well, we've seen an outbreak of this type of malware. We're going to fix it." And that work, of course, that fix has to be done by a system administrator. And system administrators happen to work and live in a different city from where Sally is. So, of course, they need to remotely access her device. Now, the way a Zero Trust system works for system administrators is really interesting. Is our system administrators, of course, their job is to, on any given day, log into 5, 10, 20 systems and fix a problem on them. And that's managed by pretty traditional workflow using a service desk, help desk, or what's called IT service management, ITSM. And this enterprise, let's say, has 1,000 servers and 500 employees. Out of those 1,500 systems, of course, our system administrators might have to log into any one of them on a daily basis, but nobody knows which device they need to log into, and they don't want to give the system admins full access to all 1,500 servers, 24/7 by 365. So what they've done is they actually utilize a Zero Trust policy that ties into their help desk. And the Zero Trust policy enforcement point will essentially make an API call to the service desk and say, are there any open tickets that, in this case, Bob has assigned to him? And if there are, it will actually set up a network connection so that Bob is a network policy, so that Bob is allowed to access those resources. For the other 99% of the systems on the network, Bob actually can't access them. It's prevented at a network layer. because there's no open service desk ticket. And that's exactly what happens in this case. Bob gets a ticket assigned to him, says, oh, I need to log into Sally's device to fix it. Because the ticket is open, he now has a network connection or the capability to do that. He remote desktops into Sally's device. He fixes it. He closes the ticket. And when he closes the ticket, the Zero Trust system automatically gets notified. It gets triggered. It updates his access. And Bob no longer has access to remotely access Sally's device. This is another example of how a Zero Trust system, number one, ties into a business process, which is really important to follow from a compliance and a good process perspective, and also makes the organization a lot more resilient. Imagine if it wasn't Sally that clicked on a phishing link, but it was Bob, and Bob had access to all 1,500 servers. That's kind of the mother load from a hacker's perspective, whereas in this world, that malware would only have access to those 5 or 10 systems that Bob happened to have a ticket for on that given day. So I hope that that's provided an overview of what Zero Trust is and some of the benefits of it. I went a couple steps down in some of the architectures around that. In particular, I talked about the software-defined perimeter architecture. I do encourage you to do some reading, learn some more about this. There are a ton of freely available resources that are available. I definitely recommend taking a look at the NIST Special Publication 800-207, as well as a Zero Trust maturity model. Both of those are available on zerotrust.cyber.gov site, as well as the Cloud Security Alliance. The software-defined perimeter architecture is freely available. A couple other resources I recommend. There's a really good book called Zero Trust Networks that came out about 5 years ago. It was kind of the first book on this subject. My book, if you'd like to read that, is kind of a follow-on to that. And then I mentioned this ebook from the Washington Post. There's one of the 4 sections of it that talks about the history of the internet and from a security perspective. Google also published a number of very influential white papers called Beyond Corp. There's about 6 of them at this point, starting in 2014. And those are also freely available from the Google site. So to recap, think about Zero Trust as a shift in security philosophy and principles. And when organizations really embrace it, it can and should change the way they think about how they're architecting their enterprise security models. And it's absolutely standing on the shoulders of giants and building on the proven principles of MFA and cryptography and network segmentation. But it's also adding something very new, which is, for the first time in many cases, bridging the gaps between our applications and our data and the network layer that we talked about. So now we'll shift gears and talk about sous vide cooking, which is slightly related to this. So sous vide cooking does actually have a little bit in common with information security. So first of all, it's a lot of fun. It uses technology in really interesting ways that we'll talk about, and it misuses terminology like we often tend to do in information security. So let's talk about and dive into this. So sous vide is literally French for under vacuum, and you can see our classic tattooed chef here working in a commercial restaurant with a vacuum sealed bag that he's about to drop in. And these vacuum sealed bags, of course, to do that, you need a vacuum sealer like this. To do it and to literally be doing sous vide cooking. And that sealer will take all the air out from the bag and then heat seal it so it is under vacuum. And the reality is you don't need to do that. You don't need that. You don't need a vacuum sealer or a vacuum for sous vide cooking. And what's happened is now the term sous vide cooking just refers to this cooking technique. And you can, like I do, use plain old Ziploc bags here without a vacuum sealer and it works just great. So let's talk about what this technique is. What you're doing in sous vide cooking is you're precisely controlling the temperature of a water bath using an immersion heater or immersion cooker that you can see at the back, usually somewhere between 140 and 160 degrees. So pretty hot if you stick your hand in it, but it's definitely nowhere near boiling. You put your food in with seasonings, and you can see someone's steak here with some garlic and some rosemary, 2 of my favorites. And it cooks for a longer period of time. And the beauty of it is it's, number one, very precisely controlled. And because it's immersed in water, the heat transfer is very efficient. You end up with food that is evenly heated throughout and exactly at the temperature that you want, down to 1/10 of a degree. It also maintains a great deal of moisture since there's no moisture leakage or evaporation. The downside is that, number one, it's not appropriate for all types of cooking, but number two is the food or the meat that comes out of here is generally very moist and a little flabby. So what you do is you'd finish it off by searing it to make it very attractive and to get the yummy Maillard reaction brown crust on the outside. So let's talk about the components of this. So first of all, you need a pot or a vessel of some sort. Everyone's got pots in their house, so you don't have to buy one. As long as you have one that's big enough for whatever you're cooking, you're in good shape. Number two, you need, you could buy a plastic or a polycarbonate container like this. Some of them have fancy hinged lids. Your choice about how you're going to do that. You also need the bags. Ziplocs are fine. Make sure they're heavy duty and BPA free, which almost all of the zipper bags are nowadays. You can also use disposable or reusable sous vide bags, something like this. Again, you can make them a little. You can make an investment, or you can use your Ziplocs. The dedicated sous vide bags do tend to be a little tougher or thicker than the Ziplocs, but they're generally, Ziplocs are generally fine as well. The most important part is the immersion cooker. And there are a huge variety out there on the market now. You can spend $100 and get a very good one. Seen some that are as low as $60. I can't vouch for how good or bad they are. And of course, you can go up to $300 or way more than that if you wish. I happen to own an Innova. I had it about 8 years and been very happy with it. They've changed the model, so the one I have is kind of between the two low end ones on the slide here. But the difference is these are really very simple devices, right? They're heating water, so you're putting a certain number of watts power in and you're heating up water. And then there's a circulator component that spins around and circulates the water. So the difference really to key on is how much power. You can see the low end one in this particular product line is 750 watts of power, and then the medium one is 1,000 watts. And then the high end one, which is much, much more expensive, is 1,200 watts and has a bigger circulator. The one I have is 800 watts. I mentioned they changed the model, and I would imagine that the 750 watt one would probably be fine for almost all uses. But do a little bit of research and see. And you can see they're pretty inexpensive. This one's on sale for $99. And as I mentioned, there's others that are even less expensive than that. You can also make one yourself. There's lots of videos and instructions on how you can do it. You can take an old analog slow cooker like this, crock pot, and hook it up to a thermocouple and a little controller device, and turn it into a project. This is kind of the Linux, the Linux approach of these, but this could be a fun project. I don't know that you're going to save a lot because you probably end up needing, to buy the old slow cooker and buy, I don't know, 30 or 40 bucks in electronics, but it could be a fun project to do. Let's get to
Jason,
Yeah.
I apologize. I gotta cut you off to close it off. We're kicking off closing ceremonies right now over in track 1. So is there anything you want to add to finish it out?
Oh dear. Okay. The only other thing was definitely take a look. There's some terrific resources online. I like Serious Eats. You can see the different temperatures for the different foods. There's a terrific explanation of why this is safe and why sous vide cooking kills bacteria. And you can make some pretty amazing and delicious things. So with that, thank you. Hope this was enjoyable for you and you learned something, and have a great day.